Okay, so we give examples. I'm adjusting the position. Okay. In section 4.3, we have the stochastic process. X sub t being the stochastic integral from 0 to t of bs times b1 minus bs, dbs. So the integrand has equal part and counterpart. And in section 4.3, we derive the value of this stochastic integral, and that is 1/2 of b1 times bt squared minus t, and then what? Then minus 1/3 of bt cubed. Let me double check 1/2. Yes. Okay, and this is for t between 0 and 1. Now, if we use the definition of the near martingale, it is very tedious to check from the definition. From the definition of near martingale. Please try and see how it works. Of course, if you are very patient, you will be able to verify the near martingale property. On the other hand, if we use the above theorem, let's see, if we use a theorem, I think theorem 3. If we use theorem 3, then we get y sub t is the conditional expectation of x sub t given f sub t. So what is this? Here we have, this is x sub t. So is the conditional expectation of x sub t is 1/2 b1 times bt squared minus t, I copy from here, minus 1/3 bt cubed given f sub t, the same t. Here is t, here is everywhere is t. Now let's work out. The first term is the second term. In the first term, this vector is measurable with respect to this sigma phi at t. And so we can bring it out. Then we can bring b at 1/2 out. And then bt squared minus t. And then the conditional expectation of b1 given f sub t. And then minus, the second term is measurable with respect to f sub t. So it's the same thing, 1/3 bt cubed. And so this is 1/2 of bt squared minus t times, now what is this conditional expectation? This conditional expectation is the Brownian motion is a martingale, so this is since t is between 0 and 1, so this is just bt. And then minus 1/3 of bt cubed. Now here bt squared times bt, we have one bt cubed, and the coefficient is 1/2. 1/2 minus 1/3 is 1/6 of bt cubed. And then minus t times bt is 1/2 of tbt. And we can bring 1/6 out. And this is just bt cubed minus 3tbt. And now you see, what is this? This is a Hermite polynomial. This is 1/6 of Hermite polynomial of degree 3 of bt with parameter t. And this is a martingale. So this proves that y sub t is a martingale. And therefore, by the theorem, x sub t is a near martingale. Hence, x sub t is a near martingale. Okay, let's go to the next page. This is page 40. Okay, let's prove another theorem. Suppose the integral from a to t over f s phi s dbs. Here I don't write, but it is understood f is adapted and phi is instantly independent. And the definition says that this is the limit as the mesh of the partition goes to 0, and then the summation I from 1 to n, and f of t sub I minus 1 phi t. Oh, okay, so I start.